We come across so many drugs in our medical world, and among them we have both natural drugs as well as synthetic and semi-synthetic drugs. We are blessed with our nature as it is going to produce so many natural drugs, and based on that we have synthetic as well as semi-synthetic drugs available in different types of categories. So it is very important for us to learn which type of drug is natural product and which is coming from either synthetic or semi-synthetic process, so that we can easily find how these drugs are going to be interrelated. Natural drugs are coming from the different sources like the plants, animals, and even marine and other types of sources. If we take an example of drug like Physostigmine is coming from a natural source like the Physostigma venenosum. So it is one of a natural product. On the other hand, we have few of the drugs within the same category like the neostigmine and pyridostigmine. These two are the synthetic products. So drugs like neostigmine and pyridostigmine are structurally related with the physostigmine, but we have obtained the physostigmine from the natural source. So nature is giving some information how we can prepare the drugs, and based on the natural drugs we can prepare the synthetic or semi-synthetic products which are having a major role in our medical world. So today in this video we will see what are the different types of drugs coming from the natural source and from which plant they are going to be obtained and how they are going to be useful, and what are the synthetic or semi-synthetic products which are related to the natural drugs. So let's go one by one. So first one is the quinine. Quinine is coming from the cinchona-alkalides, and this is the structure of the quinine, and you can observe that it is having one of a heterocyclic ring system. What is this heterocyclic ring? This is nothing but the quinoline ring system. It is a cinchona-alkalide coming from the different types of cinchona species like the Cinchona officinalis, Cinchona saxirubra, and so many types of species, and chemically it belongs to the quinoline alkalides. And these cinchona-alkalides are having so many types of natural products, and among them we have two important natural drugs like quinine and quinidine. Even it is also having the cinchonine and cinchonidine, but therapeutically quinine and quinidine are important. Quinine and quinidine are the stereoisomers which are going to differ in their stereochemistry at the two positions. Quinine is having 8s and 9r configuration, whereas quinidine is having 8 or 9s configuration. Even these two drugs are going to differ by their clinical use. Quinine is going to be used as an anti-malarial agent, whereas quinidine is particularly used as an anti-arrhythmic agent. So quinidine is a class 1 anti-arrhythmic agent. So in this way cinchona-alkalides are going to give two important drugs, quinine and quinidine. And we have a related drug, mefloquine. Mefloquine is a synthetic product which is again used as an anti-malarial agent. And here we are going to discuss what are the natural drugs and what are the synthetic or semi-synthetic drugs. And we are not going to differentiate whether the drug is a synthetic or semi-synthetic, but here our focus is on which drug is natural and which is coming from either synthetic or semi-synthetic source. So here mefloquine is a synthetic drug related to the cinchona-alkalides. Now let us go with the second example, physostigmine. Physostigmine is coming from the Physostigma venenosum, and it is having the structure like this. Again, what is our heterocyclic ring system it is having? So basically it is having a indole ring system. So physostigmine belonging to the indole alkalides. And this physostigmine is going to act as a acetylcholine esterase inhibitor, and it inhibits the metabolism of the acetylcholine, thereby it increases the acetylcholine levels within the synaptic cleft. In this way physostigmine increases the cholinergic transmission. And this drug is particularly used in the treatment of glaucoma, as it is going to increase the cholinergic transmission. So already we have seen two drugs like the neostigmine and pyridostigmine are few of the synthetic derivatives related to the physostigmine. Similarly, another example is the Tubocurarine, or particularly called as D-Tubocurarine. It is coming from the Condodendron tomentosum. And this is the structure of the D-Tubocurarine, and we can observe that it is a dimeric structure. And what is the ring system present in this D-Tubocurarine? You can observe that it is having an isoquinoline ring. So D-Tubocurarine is a isoquinoline alkaloid, and this drug is commonly called as arrow poison, because in olden days this drug is going to be applied on the point of the arrow, and when this arrow is going to be piercing into the skin of the animal, the skeletal muscles of the animals are going to be paralyzed so that the animal cannot escape. So D-tubocurarine is a skeletal muscle relaxant. It is going to block the nicotinic acetylcholine receptors, thereby inhibits the muscle contraction. So we have related synthetic drugs to the D-tubocurarine like the pancuronium, vecuronium and rocuronium, which are the synthetic derivatives, again used as a non-depolarizing neuromuscular blockers. And they are used along with the IV anastics to produce the muscle relaxation. Next one is the atropine. Atropine is coming from the tropane alkaloids like the Atropa belladonna and Datura stramonium. And it is having one of the important component, atropine. This atropine is having the tropane nucleus. And similarly, another example is the hyoscine. Hyoscine is also called as scopolamine, which is having an extra epoxide bridge at the 6th and 7th position compared with the atropine. And atropine is a racemic mixture of the hyoscyamine, and all of these are the natural drugs. These drugs are acting like an anticholinergic agents, and particularly atropine is used as an antispasmodic and hyoscine is used as an antiemetic. Few of the drugs like homatropine and benzatropine are related to the atropine. They are the semi-synthetic products coming from the tropane alkaloids. Next one is the morphine. Morphine is coming from the opium alkaloids from the species like the Papaver somniferum and so many types of Papaver species. And this is the structure of the morphine, and one of the related natural product is the codeine. So morphine and codeine are the two important natural products coming from the opium alkaloids. What is the heterocyclic ring system they are having? Actually, they are having a modified heterocyclic ring system, and we can observe it is an isoquinoline ring is present in the morphine and codeine. This isoquinoline ring is going to be modified so that they are going to produce a phenanthrene type of alkaloids. And we have so many semi-synthetic derivatives coming from the opium alkaloids like the hydromorphone, oxymorphone, hydrocodone and oxycodone. All these are structurally related and they are derived from the opium alkaloids. And these opium alkaloids are acting like an analgesics by acting on the opioid receptors. And the related drug is the papaverine. Papaverine is again coming from the same source, that is the opium alkaloids, Papaver somniferum. But interestingly, it is having a different structure. Again, you can observe it is having the isoquinoline structure. Particularly, it is a benzyl isoquinoline. This papaverine is going to inhibit the phosphodiesterase enzyme. Thereby, it is going to increase the cyclic AMP as well as cyclic GMP levels within the muscle. That's why it acts as a smooth muscle relaxant. Again, this papaverine is coming from the opium alkaloids. Next one is the digoxin. Digoxin is a cardiac glycoside coming from the digitalis lanata. Digoxin is having the structure like this, and it is because it's a glycoside, it is having an aglycone which is made up of the steroidal nucleus connected with a 5-member lactone ring. And the sugar moiety is made up of the 3 digoxose units. And digitalis lanata is mainly having the digoxin. Along with the digoxin, it's also having the digitoxin. These two drugs are going to inhibit the sodium potassium ATPase pump that is present on the cardiac membrane. As this pump is going to be inhibited, the intracellular cation levels are going to be increased, which results in the increased force of contraction. In this way, these two drugs are acting like cardiotonics. That's why they are used in the treatment of heart failure. And among these, digoxin is more preferred than the digitoxin because an antibody is available for the digoxin as well as it is having the less protein binding compared with the digitoxin. And one of the semi-synthetic derivative of the digoxin is the medigoxin. Medigoxin is also called as methyl digoxin, which is a semi-synthetic derivative of the digoxin. And medigoxin is therapeutically more better compared with the digoxin. Next one is the capsaicin. Capsaicin is coming from the capsicum annum. Capsaicin is present in the red chili and it is having the structure like this, and it is one of a vanilla amide derivative. The capsaicin is acting like a TRPV1 agonist, transient receptor potential vanilloid receptor agonist. Because of the activation of these receptors, it produces the depolarization of the nerve terminals, but later it is going to produce a desensitization of the nerve terminals, leading to decrease in the nociception. So capsaicin is going to act as an analgesic, and it is topically used in the cream in order to produce an analgesic effect. Similarly, another drug is the pilocarpine. Pilocarpine is coming from the Pilocarpus jaborandi, and it is having the structure like this. And what is the heterocyclic ring system it is having? We can observe that it is having the imidazole nucleus. So pilocarpine belongs to the imidazole alkaloids. This drug is going to act as a muscarinic agonist and it is going to increase the cholinergic transmission, thereby it is used in the treatment of glaucoma. So pilocarpine is one of the drug which is used in the emergency treatment of glaucoma and it can be used as an eye drops and it is one of a natural product among the muscarinic agonists. Similarly, Yohimbine. Yohimbine is coming from the Yohimbine bark and Yohimbine is a indole alkaloid and this drug is going to act as an alpha 2 antagonist. Because of the antagonistic activity at the alpha 2 receptors, it is going to increase the blood supply and particularly used in the erectile dysfunction. But nowadays this drug is going to increase the anxiety as it is going to stimulate the sympathetic system, and that's why this drug is not going to be therapeutically useful and it is not used clinically. And a similar drug, synthetic drug, is the Digoxin, which is again having a limited use because of the increased anxiety and other adverse effects. And the drug is the Ergotamine. Ergotamine is coming from the fungus Sclerotium of the Claviceps purpurea, and this is going to produce so many types of drugs like ergotamine, ergometrine, and lysergic acid diethylamide (LSD). Ergotamine is particularly used in the treatment of migraine, whereas ergometrine is used to prevent the postpartum hemorrhage. And LSD is one of a natural product which is used as a psychotomimetic. It is not therapeutically used, but it can be used as an experimental tool in the animals in order to produce the hallucinations and psychosis. We have few of the synthetic and semi-synthetic analogs of these ergot alkaloids. Bromocriptine is a semi-synthetic derivative related to the ergot and it is used in the Parkinson disease. Similarly, cabergoline is a drug which is used to prevent the prolactin release. So cabergoline as well as bromocriptine, both of these drugs can be used to decrease the excessive prolactin release. Methotrexate is one of the drugs which is used in the treatment of migraine prophylaxis. So all these are related with the ergot alkaloids. Next one is the Vincristine. Vincristine is coming from the vinca alkaloids Catharanthus roseus, and we have two drugs here, Vincristine as well as vinblastine. Both of these are the natural products. These drugs are going to acting like a spindle poison and they are going to inhibit the polymerization of the beta tubules into the microtubules. As the microtubules are not going to be formed, the mitotic division is going to be inhibited. So these two drugs are used in the treatment of lymphocytic leukemia as an anti-cancer agents. Drugs like Vindesin and Vinorelbine are the semi-synthetic derivatives of the vinca alkaloids. Next one is the Paclitaxel. Paclitaxel is coming from the Taxus brevifolia and Paclitaxel is well known under the trade name Taxol. How this Taxol acts? Taxol again acts on the mitotic cell division, but unlike the vinca alkaloids, it is going to act on the microtubules. The beta tubules can be polymerized so that they can be converted to microtubules, and microtubules then can be detached to produce the mitotic division. But this Taxol is going to stabilize the microtubules so that they are going to be freezed and they are not going to be detached so that the mitotic division can be inhibited. In this way again the Paclitaxel is going to acting on the cell division, but it is going to stabilize the microtubules. Again the Paclitaxel used in the treatment of cancer, and one of the semi-synthetic derivative related to the Paclitaxel is the docetaxel.